Okay, let's go ahead and get started. Thanks for joining us today. Today we're covering alarm handling and data logging, two of the more popular features with our Horner all-in-one controllers. We're going to be talking about the different features and functions, and then as well spending a lot of time demonstrating. Thanks for joining us. And a reminder, you have the ability to ask questions at any time. Feel free to type them in the questions pane on the control panel, and we'll get those answered at the end. Okay, our agenda today again is to talk about alarm handling, the functionality of it, as well as data logging. Again, like I just mentioned, we're going to spend plenty of time on demonstration, so we hope that you'll get a lot out of it. We'll spend also a little bit of time talking about some of the enhancements we have planned for these two features as time goes on. And we also, as I just mentioned, will take time to answer questions. Okay, let's dive into alarm handling. Okay, what is alarm handling? It is a feature which can be configured by system designers to enunciate and manage abnormal machine conditions, primarily alarms. It provides a means for operators to be aware of and manage alarm conditions as they occur. And it provides a means to maintain a historic record of alarm conditions as well. So it's always been a popular feature with HMI type products. And of course, as an all-in-one controller, our products combine the functionality of a PLC and an HMI with built-in I/O and networking. So that built-in HMI capability features alarm handling functionality. So in the case of our Seascape software, which is used to configure every aspect of our product, the alarm handling is configured in the graphics editor. Now we can support a fairly wide array of alarm conditions with up to 1,024 alarms in up to 16 groups. So you can have the alarms in kind of one big group if you wish, or you can kind of categorize or segregate them into different groups up to 16, maybe because the machine has different functionality or multiple zones. It just might make sense to kind of categorize and divide up those alarms into groups, or you can leave them all into one group if you choose. Now each alarm has a trigger bit, and when that trigger bit is on, the alarm is active. When it's off, the alarm is normal. And there are multiple alarm states to deal with alarm conditions. When the alarm trigger bit is active and not acknowledged, the state is said to be in alarm, and that's abbreviated with ALM in the case of our product. When the alarm is active but has been acknowledged by the operator or maybe by somebody remotely, then we call that an acknowledged status, ACK. And then when the alarm condition has returned to normal and is no longer active, we call that return to normal, RTN. And from the standpoint of the operator, there's at least a couple of actions they can take in reaction to alarm conditions. One is they can acknowledge them, typically by pressing the screen and pressing an acknowledge button that's affiliated with the alarm object. And then in some cases, they can also clear alarms if the alarm is no longer active and if the system designer has provided a clear button or enabled the clear button that's also part of the alarm object. Okay, now there's two types of alarm information that can be displayed to the operator. There's alarm summary information. Now, alarm summary information is all about the current status. What's going on right now? Are there any alarms currently active? Any alarms that are currently active and have been acknowledged? So alarm summary information is only concerned with current states of alarms. Then there's also alarm history information. With alarm history information, it really isn't all about what's happening right now, but it's more of a historic record of what did happen in the past. You know, what alarms came active and when, what alarms were acknowledged and when did they return to normal. So those are the two types of information that the OCS can present to the operator, and you can present that information in different places on multiple screens, depending on the application and the situation. Now, in addition to the two different types of information that can be presented, The alarm information can be presented in one of two graphical forms. We have what we call an alarm window, which effectively is a window into the alarm conditions, either current or historical. And through that window, you can see typically the last few alarm conditions, depending on the size of the window, because you can resize that window to be, almost the entire screen if you choose, or just a small portion of it. And then when you press that window, you get further detail as the alarm object itself temporarily takes full control of the screen. Now, in addition to the alarm window, you can also configure an alarm button. The alarm button on its face does not show a lot of detail. At a glance, you can really just see through its color if there are any active alarms or any alarms that have not been acknowledged, etc. However, once you press that alarm button, then again, the alarm object takes full control of the screen and additional details are displayed. Okay, so enough talk about alarm handling. Let's do a demonstration and show how it is configured, and then we'll also show how it operates at runtime.
Let's take a look at how we would configure alarms in Seascape. Okay, so to configure alarms, we actually need to start from the graphics editor. So I'm calling up the graphics editor here. As you can see, we have well, it may be obvious to you, we have an XL4 controller that I'm going to be setting up for alarm handling. So from the graphics editor, I'm going to go to config alarm. Okay, so this is where I do all the setup for alarms or alarm handling as a feature. Okay, so the first thing I'm going to do is I'm going to determine how many alarms I want to support. And you can support literally hundreds of them. So I'm going to go ahead in this simple example, I'm just going to go ahead and support 8 alarms. Okay, next we have to assign a series of bits. Each bit represents 1 alarm. So in this case, I'm just using the traditional register-based ladder. I'm going to go ahead and use internal non-retentive bits for my alarm status. I could use retentive bits. I could use registers. I have my choice. So in this case, I'm going to go ahead and assign T1025. Notice I used an address that is on a word boundary. So T1, T17, T33, etc. Those are word boundaries, and T25 is as well. Okay. Next, I have the option, it's not required, I have the option of assigning 2 additional bits for remotely acknowledging and remotely clearing. So generally, you acknowledge and clear alarms from the screen. So that's typically an operator function. However, let's say you have a SCADA package or some other need to remotely acknowledge or remotely clear an alarm. So you can assign bits here for that purpose. Now, keep in mind that these currently are strictly for acknowledging all the alarms or clearing all the alarms. They're not individual bits for individual alarms, but they're also optional. So I'm not gonna assign those here. Okay, next, because we selected 8 alarms, I've got 8 blank effectively or default alarms listed here. Alarms 1 through 8. And these will be tied starting at T1025. So the bit that will cause alarm number 1 to turn on is T1025. To turn alarm number 2 on, that's T1026, etc. And we'll show in ladder how those can be, tied to machine conditions in a little bit. All right, so next what I'm going to do, instead of having these generic alarm strings, I'm going to go ahead and type in what these alarms mean in my particular case. So I will double click here on this undefined alarm 1, and let's make that under temp zone 1. Okay, the next alarm will make over temp zone 1. Now, One thing you'll notice, it could take quite a while to type all these alarms in. You do have the option of copying and pasting these to and from Excel. So that can be much faster than doing what I'm doing here. But I'm only doing a few alarms, so I'm going to go ahead and type that in. Let's see, let's make this PSI fault zone 1. All right, I'll type in a few more alarms here. Let's do a motor overload. And lastly, let's go ahead and make this an e-stop trip. Okay, the next concept I want to talk about is the concept of the ability to group alarms. So as you can see here, by default, there's a column showing group 1. You have the ability to create up to 16 different groups of alarms. So if you have a machine with maybe different zones or different functions, and you would like to group your alarms by zone or by function, you have the ability to do that. So as you add alarms, whether it's directly here as I did, or say through Excel with the copy and paste function, you have the ability to assign different groups to different alarms if you choose to do that. In this particular case, I'm just going to go ahead and leave this alone, leave everything in a single group, group 1. Now there's a variety of other things we can configure here, but I think I'm going to come back to that after I've kind of gone through how you utilize alarms on the screen. Okay, let me go ahead and hit OK here. Now, when it comes to displaying information on the screen in regards to alarms, we utilize what's called the alarm object. So that icon is accessed here. It's the one with a alarm clock icon. And I'm going to go ahead and select that and then click and drag. Okay, so by default, when you use the alarm object and place it on the screen, it creates what we call an alarm window. So that basically is a device or a object that is showing you a few lines of information in regards to alarms. And that can either be what's currently happening with alarms, an alarm summary, or it could actually be what's been happening with alarms or an alarm history. So let's go double click this object and let's configure it. Okay, so the first thing we can configure is, indeed, are we going to configure this device as a summary of current alarms or to show history of what's been happening in the past? So in this case, let's go ahead and make this a summary. Okay, the next thing we can configure is whether we want this alarm object to be a window, as it is by default, or if we just want this to be a button. In other words, okay, we only want to show a quick small button on the screen that by its color will indicate whether there are any alarms or not. So let's go ahead and do that before we configure anything else. Hit OK, and now you can see our alarm window has turned into a button. And in this scenario, we're probably going to configure it something of a more reasonable size that, again, on a screen that has other information on it, allows the operator to see at a glance what's happening with alarms, or at least to see by the color of the object what's happening with alarms. Now, what controls the color? Well, if we go back to our alarm configuration, we can see down here under the summary button colors that when we have no alarms, it's empty, it's going to be green. When we have alarms that have not been acknowledged, it's going to be red. And when we still have current alarms, but they've all been acknowledged, that button is going to be yellow. So again, the function of a alarm button is a small object that at a quick glance allows the operator to see what's going on in general with alarms. Now at runtime, you can actually press this button and then see all the details. Okay, and we'll show you that in the runtime portion of the demo. Okay, so here we've configured what we would call an alarm button. And in this case, double clicking again, you can see we've tied that to what's currently happening with alarms by defining it as a summary of current alarms. Okay, a few other options that we can configure We talked about groups a minute ago. So you can configure which of the 16 groups are included when you're looking at the details for this particular button. And then when an operator presses the button, they're going to see further details of what's happening. And this allows you to configure how that list information is presented, what font size it's in, what format for the date and the time, and if you want the state, is it unacknowledged, acknowledged, in alarm, return to normal, etc. You want the state displayed as well. Okay, so let's go ahead and wrap that up as an alarm button. Let's go back, select the alarm object again here through this icon. Now this time, let's go ahead and leave this object as the default alarm window. But this time when we configure it, let's configure it for alarm history as opposed to an alarm summary. So this particular object is going to show us the history of what's been happening with alarms. When did they go into alarm? When were they acknowledged? When they were returned to normal, etc. And then the specifics of what I guess states are actually recorded here under history. Let's go back again to our alarm config and see where those can be set. So up here in the upper right-hand corner, that's where you have the ability to define for basically a history object, what particular events do we want to record? And then by default, we're pretty much recording them all. All right, one more thing I want to show you in terms of configuration here, and that is you do have the ability to configure a removable media log. So what is this? Well, this is the ability to record what's happening with alarms to a file on your memory card. So I'm going to go ahead and enable that here. All right, you can configure the frequency of when new files are created, and the default is daily. So if you want every day to create a new file with today's alarm history happening, then you could select daily. If you're looking for something weekly, monthly, yearly, you have those capabilities as well. You can define an alarm log path. So let's say that we want this to go in a subdirectory called alarms. And then you can select your time and date format, and as well as your time format here. And then you have a status register that you can define that will allow you to monitor the process to make sure everything is working properly. Okay, so that is the alarm log that again is optional that you can make to the removable media card. All right. Next, let's take a look at how these alarms are triggered. Okay, so we've effectively, if we go back to the configuration, we've assigned a series of bits, in this case 8 consecutive bits starting at T1025 that will enunciate alarms. But how do those alarms get tripped? Well, that's where we depend on external events that may be documented in ladder, for instance. So let's go back into ladder and take a look at how that might work. Okay, so in this area of logic, I have created some simple ladder logic that effectively is defining what causes each of the alarm bits to turn on. So in the case of my low temperature alarm, I'm just checking to see if the temperature that I'm monitoring by the OCS, if it's below the threshold for an alarm, then I'm going to trigger the bit. For a high alarm, similar, but a greater than instruction instead of a less than instruction. In the case of my pressure being out of range, I'm using a limit instruction, which basically says, in this case, if the current pressure is outside of a certain range of limits, and that has occurred for 5 seconds, then I'm going to turn on the pressure alarm bit. In the case of a motor overload, it's strictly a matter of a bit turning on or off that's directly wired into an input. That's going to cause me to effectively turn on the motor overload alarm. And then lastly, an e-stop trip, similar type scenario. Okay, so now that we've showed you how to configure alarms, let's go take a look at how they work at runtime. Here's an Excel 4 running a demo program very similar to what we just configured. I'm looking at an alarm status screen, which contains an alarm button. Now, an alarm button indicates the current status of alarms in terms of its color. So it's currently green, which indicates no alarms. But if I want to see details, I have to actually press the button in order to see details. But at least at a glance, it can show me, do I have any current alarms? Have they been acknowledged? Or is everything normal? I also have, in this example, I have an alarm history screen, which contains a window which shows me details that I can see in this case, for the history of what's happened with alarm. So when they went an alarm, when they returned to normal or were acknowledged, those sorts of details are shown, and I don't have to necessarily press the button to see the last few events that have happened. Now, if I want to see a more complete history, then I do have to press that object in order to scroll back through the last, through more than the last few alarms. Okay, let's go back to the status screen and let's go ahead and simulate an alarm condition. So let's say we have an over temperature condition occur. All right, so I'm simulating that here, and you can see that our alarm button has changed from green to red. So that indicates to the operator, hey, you've got a new alarm. So as the operator, if I press that button, I can now see the details. When did that go into alarm? And what specifically is the alarm? In this case, an over temp for zone 1. So typically an operator at this stage is going to go ahead and acknowledge the alarm and escape out of the details screen there. And you'll see that the alarm status button has changed to yellow. So that indicates that, yes, we still have an alarm condition, but it has been acknowledged. Now, if we go and take a look at the history, we can see both when the alarm occurred and secondly, when it was acknowledged. So that is what the alarm history shows. It kind of records when things occurred, not strictly just what's happening right now. Okay, let's go back to alarm status. And let's go ahead and trigger a new alarm. Let's say somebody presses the e-stop. Okay, once again, it's red. But let's say it's the operator who is pressing the e-stop. So he's not going to acknowledge the alarm because he's busy making adjustments to the machine with the e-stop pressed. Going to take a look at what's going on with history. We can see, yep, the e-stop has indeed tripped. And then let's say that the operator is done with adjusting the machine and he goes ahead and restores the e-stop to normal. So there you can see we've got a return to normal situation that has occurred. And if we go back and take a look at the status, you'll see if we zoom in there, that from a current alarm standpoint, if the operator is the one who put it in, who kind of caused the e-stop and then didn't acknowledge and then went ahead and cleared it again, from a current alarm standpoint, he never really sees it. However, again, going back to history, we can certainly see that that did truly occur. Okay, so that's a quick look at the alarm button and alarm window and how they work at runtime.
Okay, so that was a demonstration, obviously, of how to set up alarms and how they work at runtime. All right, let's take a look at some future enhancements that we have in store for alarm handling, because we're not that far away, just a few months from having Seascape 10 available. And we have a lot of new capabilities built into the alarm handling with Seascape 10. So, and these are a combination of different feature requests, for instance, that have been asked over the years. One example is dynamic alarm messages with embedded data. So if you remember in my demonstration, I typed in alarm messages like, a motor overload bit or over temp zone 1, those sorts of things. Those were fixed messages without any variability to them. So You'll have the ability to have dynamic alarm messages that also can have embedded data, one or more data fields in there. So it could be, over temp alarm zone 1 with the actual temperature that was captured at the time of the alarm, for instance. So that's a requested feature for sure. Also, if you remember, for remotely acknowledging and clearing alarm conditions, say from a SCADA package or elsewhere, you really only currently have one set of bits for acknowledge and clear, whereas in the future, you'll have one bit per alarm. So that was definitely another highly requested feature. We're implementing multiple severity levels so that when you configure an alarm, you can also configure its severity and then indicate that to the operator. So they will have the ability to say, okay, this is just informational, it's not that big of a deal. Or, okay, this is a warning, it's not that big of a deal. Or, oh my, this is a critical alarm, I better do something. And then another highly requested feature will be the ability to have level-based alarms. So every alarm we have today depends on a trigger bit. And if you're just looking for a value to exceed or be below a certain threshold for, say, an analog value or a floating point value or something, you still have to put in some very simple ladder logic or IEC logic in the case of IEC to effectively trigger that alarm condition. Whereas coming up likely with Seascape 10.1, we'll have level-based alarm options, so you can have alarms that are triggered like the current ones are, or selectively you can have other alarms that are strictly level-based, for instance, with high alarm levels and low alarm levels and high alarm levels and those sorts of things. So there's plenty in store for enhancements to alarm handling in the future. All right, let's go ahead and move on now to data logging. So data logging is a feature that we were really kind of pioneers in. The XLE, believe it or not, has been around for well over 10 years, actually, closer to 13 or 14 years now. Even though we have updated it a couple times with, faster processor and newer parts and those sorts of things to keep it going because it's so popular still. Again, the XLE being our entry-level XL series product, but that product was the very first product, industrially at least, that supported micro SD memory available in the world. At that point, the cell phone providers were just kind of starting to design it in. So what we did was we kind of not only anticipated the ability to, maybe maintain a machine or an OCS through a memory card, but also kind of anticipated how popular, logging machine data could become. And it truly has become that way. I mean, early on, maybe only a few percentage of all the units we sold, even the ones that had memory cards, people actually, only with a small percentage of them, do people actually use the data logging capability that we built in. So what is data logging, first of all? Well, it's a feature which allows the controller to record machine data as prescribed by the system designer. So effectively, you can log whatever data is important in the application. It could be process data. Maybe you've got a industrial oven that is being controlled by one of our controllers. You may have the process information, possibly temperatures and maybe conveyor speeds as a product goes through the oven. So there's a variety of things, of variables that could be important in that application, and we give the system designer the ability to choose those and to quickly and easily set those up. Now, the data that is logged is recorded to a CSV file, so it can easily be imported to programs such as Microsoft Excel, where it can be analyzed, graphed, all those sorts of good things. And the other great thing about our data logging feature is configuration is really straightforward. It requires very few steps. Now, before we had a data logging feature, we had customers doing data logging and we gave them examples on how to do that, but they had to build their own data logging using removable memory function blocks. Now, we still support those removable memory function blocks, but it's a lot more work to record data, whereas the data logging object, which you'll see in the demonstration portion, is really just a matter of filling in a few blanks. And why is data logging important? Well, machine users more and more want to extract more information than ever from their machines. They just don't want to make parts. They need to validate the process that those parts were made in. They may need to measure machine efficiency, and having historical data can help them do that. They may want to take a look at the historic operation of the machine for other reasons, maybe for diagnostics, yes, but also maybe for preventative maintenance purposes, for instance. So there's a lot of reasons why customers want to have data out of their machines, and data logging is a great way of getting that done. Okay, so from a features standpoint, data log files are recorded to removable media, and that can either be a micro SD card plugged into the micro SD slot, which is considered kind of drive A with our products, or the default drive, or you can actually data log to USB if you've got a USB drive plugged into a full-size A port on all of our products that support those particular ports, and that's considered the B path to log to that particular drive. Now, data log files are configured as a group of variables. So a system designer would decide, okay, I've got this group of variables that I want to log or record the values of, and I want to group these together. And you can have up to 30 variables in a single group, which would then be logged to a single file, and up to 100 variables per application. And we're looking at in the future of increasing those numbers, and we'll talk about that later. Now, readings are taken how often? Well, they're taken either on a periodic basis, time basis, every second, every minute, every hour, whatever makes sense in the application, or on an event basis. Whenever a particular condition occurs, it can be detected by the logic, a bit can be turned on, and a reading can be taken. Now, after readings are taken, especially those that are happening quite frequently, say every second or so, they're buffered into RAM prior to be written to removable media. Now, writing to RAM is a much shorter, quicker process than writing to removable media, which takes a little more time. So that's why we buffer them to RAM. Also, that gives the users the ability, because we do have a buffer, to potentially swap out a card without losing any data, because the data is being buffered while the card is missing. Okay, with no further ado, let's demonstrate how to set that up with Seascape, as well as how to use it at runtime.
Okay, so I've got a sample program here that's doing process control. Now, generally, you're going to want to add data logging at the end of the development process. So I've done my logic. I've got my user interface pretty well defined. So what I'm doing here in this example is I'm doing process control using PID. So I've got everything tested and running the way I want. Now, towards the end of the process, I'm going to go ahead and add data logging to the functionality of the OCS controller. And you can see here kind of the parameters, or some of the parameters that I might want it to be monitoring via the data logging feature. Okay, so when we configure data logging, we perform this from the program menu, and there is a data log configuration option, as you can see. Okay, so the first step is to enable data logging as a feature. So you check this checkbox here. All right. The next step is to configure the global attributes for data logging as a feature. So I'll hit global attributes. The first thing it's asking for is a global status register. Now, the global status register is actually two 16-bit registers, and we're going to monitor these registers to make sure that there are things like micro SD cards installed in a unit, that the micro SD card isn't full, those sorts of things. So I'm going to go ahead and assign a status register to this. I believe I had kind of predefined one at register 200. There you can see. Okay. The next thing we need to assign is a global enable register. So if we wanted to be able to turn data logging on and off, then we would need a bit to be assigned, a bit type variable to be assigned, that we can therefore turn on and off to turn data logging on and off. Now, in my case, frankly, I want data logging to be on all the time. So I'm just going to go ahead and assign the always on bit here. Okay, so we've enabled data logging as a feature, and we've configured a couple of things under global attributes. The third step is going to be to add a group to configured groups. Now, what is a group? Well, a group is a collection of variables that you are going to data log on a consistent interval or all at the same time, maybe based on a trigger, but all these variables are related to one another. They don't have to be the same type. They can be a mixture of Boolean and real and integer, etc. But ultimately, you will be logging this collection of variables to the same spreadsheet, if you will. If you want to think of it as a spreadsheet. Okay, so we have to add what's called a group. So when we do that, it asks us for a group name. Now, the group name effectively is also going to be the name of a folder in which these data log files are contained in. So for my purposes, I typically keep the group names at 8 characters or less, just to make it easy to take a look at folder names and those sorts of things without getting these huge names. If I'm going to be looking at a directory on the OCS itself, I want nice short file and folder names. Okay, so let's go ahead and call this process. All right, so this process is the name of the group. It's also going to be the name of the folder in which the data log files are going to be contained. All right, so I'm going to highlight the process group. Now I want to add variables to the list. What variables are going to make up this group? And with the data logging feature in Seascape, you can have up to 100 variables total, no more than 30 variables per group. So that's the limits you're working with then. At some point in the future, we'll be raising that, but that is the limits as of today. All right, let's start by adding variables. Okay, one of the variables I want to add is a variable that tells me if the unit's in manual mode or not. So that's a Boolean variable. Let me go ahead and pick Boolean off the list. There we go. All right. And I'll look for manual mode here from the list. There we go. All right, so that's the first one I've added. Next, let's take a look at our actual temperature value. Let's go ahead and add that one to the list. That one is going to be, in this case, in my application, that's a floating point or a real value. So let me look for temperature. There it is, temperature F. All right, I've added that to the list. Let's take a look for our set point. All right, I'm going to add another variable, another real variable in this case. Okay, pulling it off the list here. Set point, got it. And then let's go ahead and put a couple of our tuning parameters for our coefficients as part of the data log group. So let's start with, and these are all integers, by the way. So let's look for our, what would we have here? We would have our process variables that we're looking for. There we go, process KP. All right, and then let's go ahead and add the process KI. All right, and then finally, let's go ahead and add the process KD. So as you can see, if you do this at the end of the process, I've done my control, I've done my screens, I've got everything pretty much ready to go. I just want to add data logging. All your variables will already be named. At that point, you'll have a good idea of what it is that you want to log and keep track of and document over time. And so again, that's a good time to be doing the data logging configuration. All right, so again, to recap, I enabled data logging as a feature. I added a status register as well as an enable/disable bit. In my case, I'm enabling it all the time. I created a data log group called process, and then I've got a collection of variables that make up that group listed here. The last thing I need to configure are the attributes for that group. So those group attributes are going to tell us important things such as, how often, or what's going to cause us to actually take readings or to actually take a log in the case of this particular group. But let's start from the beginning. So whereas we had a group status that we previously defined, we added a couple of variables for defining, is the media inserted and okay? Is the media not full? That sort of thing. We can also have what's called a group status register as well. It also is 2 consecutive registers, one being an error code, whereas if there's something wrong, you can read the status of an error code. Or if everything's good and normal, you'll get a reading for that as well. And then we have a second register that we can monitor that's going to tell us if an internal buffer that's assigned to this particular group, if it's filling up or not. Now, what is a buffer? Well, when you go and actually do data logging at runtime, so when the OCS effectively starts gathering data and then writing it to the memory card in the CSV format that can be later be pulled into a spreadsheet, for instance, it's going to first read the data in to be logged into a RAM buffer. And then it's going to accumulate data, and then at some point, periodically, it's going to write that data to the memory card. Now, if somebody were to pull the memory card from the OCS, well, obviously at that point, the data can't be written to the memory card. However, it doesn't necessarily mean that all the data is going to be lost, because the OCS allocates a certain amount of space to buffer the data to be logged before it's written. So you can monitor the second of these two status registers here to determine, hey, is the buffer, how full is the buffer? And as the buffer fills up, you can then see at some point that, hey, I better get that memory card back in, or else I'm going to start losing data. So let's go ahead and assign a status register here for this particular group. I'll just name it group status. Okay. All right. Next, I can configure the interval at which I'm going to be taking readings. Okay. Now, the fastest I can take readings or take data logs on an OCS is once per second. That's pretty fast. And you can accumulate quite a bit of data pretty quickly, as you can imagine. Now, depending on the interval that you select, the OCS will automatically determine how often it needs to create a new data log file to be sure that you don't end up with ginormous files that you have difficulty handling. So if we were to go ahead and leave this, say, at once per second, that as the data logging interval, then automatically the OCS is going to go ahead at the top of every hour, it's going to decide to go ahead and create a new file. And that file name is going to be composed of the date and the time, and it's going to be contained in the folder for that particular data log. In our case, remember, we named the folder or the group process. So that's the folder that all the data log files will be housed under. But let's go ahead and leave it at once per second, which is as fast as we can do it. Next, we can configure a path if we'd like. Now, I mentioned the fact that the process folder, based on the name we created for this group, is where the data log files are contained. However, you can also put the process folder beneath another directory in the memory card. So for instance, if I want all my data logs, including this one, to be under a folder called data log, so effectively the path for the file is going to start at the root directory. There'll be a data log folder, and then contained within the data log folder, there will be a process folder, and beneath that folder is where all my data log files will be contained. So if I don't put anything here, the folder containing the data logs will be housed at the root. If I do put a folder here or even a longer path, then it'll be housed there instead. And then I have the ability to configure date and time. Okay, now what if I'm not really interested in logging on a time basis or a time interval, but I'm interested in logging whenever a certain event occurs? Well, if that's the case, then instead of selecting an interval here, for instance, I could select triggered logging only that you can see here on the bottom of the list. If I select that, then effectively, it won't be time that will cause me to take a data log, but it will actually be a trigger bit or a manual trigger variable. When it turns on, the leading edge of that variable will cause me to take a reading. So that's another option that you have with the OCS. So let's go ahead and leave this at once per second. Okay. All right, so effectively I'm now done configuring data logging for this one data log. Again, it's enabled as a feature. I've got status information here that I've assigned and an always on contact in my case, because I always want data logging to be enabled. I've assigned a group of variables and I can have up to 30 per group. And I have defined what's going on with this group in terms of how often am I taking readings. In my case, I'm taking them every second, and I'm putting them in I'm putting my process folder underneath another folder called Datalog. Okay, so I'll say okay, and let's go ahead and download this to the controller. Okay, now let's take a look at data logging at runtime. All right, let's start by taking a look at the status information that I went ahead and put online here. So at the top, we have our global data log status, and we are ready is our current status, and percent full of the memory card is basically 0. Our buffer is normal, and you can also see that our buffer is basically empty as well. So everything looks good there. Let's go back to our process loop. All right, now let's go in and take a look at the memory card. Let's see what we've got in our memory card here. So I'm going to go to the system menu. Now I've got a EXLW controller here, so I need to find the right spot to call out the system button. All right, now let's take a look at what we see here. Okay, I'm going to go to the removable media menu item, hit enter, and you can see right away that I've got a data log directory here. Okay, so if you remember correctly, that was the directory that contained my folder, which I named process, that then contained my data log files. So let's go take a look at that particular folder here. Now, there's been some elapsed time since I downloaded the file till I'm showing you this here. And you can see I've got 2 files that are complete and not updating, and I have a third one that's updating. And if you can see here, the file name is built around the current month, which is September 09, the 15th day of the month, which is today, and also the 15th hour, which is 3 o'clock. So 15, 16, and 17 means data logging starting at 3 o'clock, 4 o'clock, and then 5 o'clock. And then the data logging that starts at the 5 o'clock hour is ongoing. Okay, so it looks like our data logging of all the data we were interested in every second is currently happening. Okay, the next thing I'm going to do is I'm going to go ahead and pull the memory card. Okay, because if you remember correctly, even without the memory card, we can continue to log. All right, I've pulled it now. So if I go back in and take a look at the system menu, I probably didn't really need to leave it there. Let's take a quick look here. Got to get the right spot there. All right, removable media. It should show that there's no card present. Got it. Okay, so no card present. Let's head out and let's take a look at our status again. And you can see ever so slightly there that our buffer, okay, for our data log, which keep in mind, we're logging every second, it's slowly filling up there, very slowly. And then you can also tell under media status that our card is now not present, okay? So the buffer looks good, its status is still normal, but it's slowly filling up, and our media status is not present. Now, if I push that memory card back in, okay, now it's ready, and it took it a minute to read it. So briefly, we got some information under full, and then that cleared. And then as you can see, our buffer status, that status bar there that was slowly filling up, that's now empty as well because our buffer is completely empty. Everything we had stored in our RAM buffer has been written to memory card. Okay, so the next thing we're going to do is we're going to take a look at the files that are written on the data log. We're going to take a look at those CSV files on our computer. Okay, so I've removed the memory card from my OCS. I've put it in a card reader and inserted it into my computer. Let's take a look and see what we've got here. Okay, let's go to the E drive. All right, and there we go. We've got our data log folder, along with our process folder, and there's those 3 files again. So let's go ahead and open one of those up in Excel and take a look. Okay, I've opened up my data log file here in Excel, and let's take a look at what we have here. I'm going to stretch out a couple of the columns so we can read the headers completely. Okay, there we go. All right, so what do we have here? Well, you can see in our data log file, the first row is our header row. So the OCS has automatically placed headers. Header was placed for date, time, and then we start with the IO names or the variable names for each of the variables that's been included in our data log as part of this group. So we've got manual mode, which was Boolean, so it's going to be 0 or 1. Temperature, which is in degrees Fahrenheit in this case, a real number. Set point, which is also a real number. Process KP, process KI, and process KD. The P, I, and D coefficients for tuning our loop. You'll see the very first log was at the very top of the hour, because keep in mind, we're logging data every second, and effectively the OCS is automatically going to create a new file at the top of every hour. Now there's a couple exceptions to that. So when I first enabled data logging, which in my case was when I downloaded the program and made sure it was in run mode, it will immediately start data logging from that point. So let's say it was 5 or 6 minutes after the top of the hour, or really any time during the hour, it'll just immediately start at that point, and then it'll finish at the end of the hour. And then the next log will start at the top of the hour. So if possible, all logs start at the top of the hour. And you can see our first entry in row 2 of data was exactly at 4 o'clock, and here's the data at 4 o'clock. And then every second after that, we add a new entry. And that will go on all the way down for the interval, which in this case is 1 second. And so there's going to be 3,600 entries in this data log file, 60 seconds per minute, 60 minutes per hour. Okay, so that's what a data log file looks like on your computer.
Okay, hopefully that was good information for you. Okay, let's take a look at some of the future enhancements we have planned for data logging. As I mentioned a couple times during the demo, we are looking for sure at supporting more variables per application. Currently the limit is 100, and supporting more variables per group. The current limit is 30. I can't tell you precisely what those new limits are going to be, but they will be significantly higher. Keep in mind, we have to allocate RAM and other memory buffers whenever we do data logging. So there's a reason why we put limits on it. But there are ways certainly that we can reallocate and free space and add more variable support for data logging. Another feature we're working on is to give you a little more control over when new data log files are created. When we initially created the data log feature, we wanted to be really sure that customers could very easily configure the feature, and for the most part, they wouldn't get themselves in trouble by creating huge files. So that's why we said, hey, if you're logging data every second, we're going to create a new file every hour. Maybe if you're logging data every few minutes, we will create a new file every day. And even if you're logging on an event basis through a triggered read only, we're still creating a new data file every day, which some people don't like. Now you can overcome that by kind of rolling your own data logging by using removable memory function blocks, but that's a lot more work. So we will provide some additional control in the future to give customers, specifically those who are a little more power users, the ability to precisely control when a new file is created. And then we've also taken a look at different encryption options as well, so that the data can be encrypted. For some applications, that's a requirement. Okay, so that's what we have planned, some of the things we have planned for data logging. All right, now we've come to the questions and answers session here. Let me see if we have any questions. Okay, let me go ahead and pull this out here. Let's see, what is expected to happen with the alarm history if we power cycle the unit? Okay, so that's a good question there. Effectively, what happens when you power cycle the unit is you are doing an auto clear on the alarm history. Now, when you're looking at an alarm history window, you're seeing when alarms, went into alarm, when they were acknowledged, maybe when they returned to normal, those sorts of things. And then if it's enabled, an operator could go in and actually clear the alarms once they're done. Now, the alarms that aren't cleared manually by an operator, they will be cleared kind of automatically in the next power cycle. So I would expect that that is another thing we're taking a look at in terms of providing users with a little more control over that. And one thing I do want to mention also is that one of the benefits of the alarm log, the actual CSV file that we create every time something happens with alarming, that's one of the benefits of the alarm log if you enable that feature, because it's going to write all those transitions, all those events, it's going to write those all to a removable memory card, to a CSV file, and have that recorded forever. So yeah, it is true that you do have kind of an automatic clear occurs at the power cycle. Okay, another question we have is, can cloning an FTP be directed to USB like data logging can? FTP definitely cannot, and I don't believe cloning can either. So I believe a lot of the functions that are removable memory related can be done with either micro SD or USB, but not all of them, certainly not yet. So data logging is one of the things you can do with both types of media, those sorts of things. And there's several other, I can't think of off the top of my head, but there are quite a few. But I'm pretty sure that cloning and FTP are not ones that we can direct outside the micro SD card yet. I'm sure that's something we're taking a look at. You mentioned some of the new alarm features won't be available until Seascape 10. Any idea what the release date for Seascape 10 will be? That's always the magical question, right? Release dates. It wouldn't be a webinar if we couldn't get questions about release dates, and rightly so. So I'm expecting we're still, we're looking at close to the end of the year before Seascape 10 is going to be available. Almost certainly, we'll start to, roll out some pre-release versions just to some testers, outside of Horner. We've been testing it internally for a while now, but we're pretty close to getting it outside of the Horner employee group to start testing it. Okay, for triggered data logs, is there any thought towards allowing system designers to configure the file names? Yes. So again, I did mention that we are looking at the ability to control when files are created. Part of that whole scenario, I'm sure, will include some more flexibility in terms of how the files are named. Today, if you notice through all of the demonstrations that I did, everything related to data logging, the names were always based on date and time. And then what kept them from being overwriting each other was the fact that data logs are all housed in their own unique folder name. So you can have multiple data log groups. Maybe this log of parameters called process, I'm logging those every second. Those are my process parameters. I've got another set of data, maybe that's, who knows what that is. Maybe it's, production counts or something, and that's logged on an event basis. Maybe I have another data log in a different group. And those three groups, all their files are all located in separate folders. So that keeps them, even if they may have similar names because of date and time, that keeps them from overwriting each other. So I'm sure we'll provide some additional flexibility there as well. Let's see. In other words, maybe this is a follow-up from that previous question. Let's see. In other words, there is a persistent buffer for alarm history. If so, what is the size? Let me think about that one for a second. A persistent buffer for alarm history. Okay, so the alarm history that survives a power cycle is the alarm history that's written to removable media if you select that option. There's a RM log under the alarm configuration, if you select that option, then that's really where the permanent record is going to be recorded. One other thing to keep in mind, another kind of quick preview of a feature that's being planned is also as part of kind of Seascape 10. One of the other features that we're adding that's very similar to, I guess you could say very similar to the current alarm log to removable media, is we are planning on a feature whereas every time an operator logs in or logs out, every time a data value is changed, maybe whether it's a set point or whether it's a PID parameter or something from the screen, that information will all be logged, and so it's available for auditing capabilities, that sort of thing. But in terms of today's functionality, permanently recording when alarms happen, when they return to normal, et cetera, that all would need to happen through the RM log to removable media. Let's see. I got a shout out for still using Windows 7. Pretty funny. I actually have Windows 7 and Windows 10 on different machines. But as you can see on my demo unit, the one I'm using for recording all of the demonstration videos, I'm still using Windows 7. So I'm sure I'll have to upgrade at one point in time. Can the data log files be read and or managed remotely? They certainly can be accessed over FTP, no question. Again, as long as you're logging to the default of microSD, then microSD is all accessible over FTP, file transfer protocol. So that allows you to read and write those files. And then many of you sat in, I'm sure, on our MQTT presentations that we did. MQTT is a push protocol that allows you to push data from the OCS as opposed to having to pull it out. And we are, I'm sure at some point, we will add the ability to push files in addition to pushing live data. So today we're just using MQTT with a Sparkplug profile, and we're just pushing data. We're not, variable type data, for instance. We're not pushing file type data yet. At the point in the future where we start pushing file data as an additional option, I'm sure data log files will be a popular thing to push. Another question, good question. Do you have plans to develop an FTP client to automate the data retrieval process? So another approach to that, which is kind of like a push, would be for the OCS controller itself to use FTP, but again, instead of being the server, where it's dependent on an external client running on a computer or something to pull data from it, it would have the ability to, to effectively be an FTP client and write that file to a remote file location. That's something we've looked at. I'm sure that's something we will incorporate in the future, but we haven't gotten there yet. Let's see, next question, a feature request. Data logging with access to text tables for logging text as an alternative to strings and the registers they take up. Okay, that's a good point. So today I believe you can data log with ASCII. I believe that's an option today. We talked about the fact that you can choose variables that are integers or Boolean or double integers or reals, whatever mix you want. And I believe ASCII is a choice as well. Here's a feature request to support text table type information. So what is text table? So if I have, let's say I have a machine that's got 3 different modes, hand, off, and auto, and I don't just want to display 0, 1, and 2 on the screen. Well, in that scenario, I can set up a text table so that when the value of the variable for machine mode is a 0, I could display hand for the operator. When it's a 1, I could display, auto and 2 off, whatever the case may be. It's a representation, a textual representation of numeric data. So that's a feature request, and I'll definitely send that up the flagpole. Okay, I think that's the end of our questions for today. Thanks for your time. I do appreciate the time you took with this webinar. And if you have further questions, feel free to email them to me at chuck.ridgway, just like it sounds, at heapg.com. Once again, thanks for joining us and have a great day.